I am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today we are going to discuss about problems on test of hypothesis for single mean and difference of means. As we have discussed, the test of hypothesis for single mean and difference of means, the formula of test of hypothesis for single mean is Z equal to x bar minus mu by sigma by root n, where x bar is mean of the sample and mu is mean of the population. Sigma is standard deviation of the population, n is sample size. And the confidence interval for single mean is x bar plus or minus z alpha into sigma by root n. See, according to this problem, the mean of random sample is given. That means x bar value is given 11,795 because it is mean of the random sample. Similarly, and standard deviation, sample standard deviation is denoted by S. This value is also given. And if sample size is 50, that means sample size is denoted by small n. Find 95% confidence interval for the single mean. Find the 95% confidence interval for the single mean. 95% means alpha value is 0.05. Level of significance is 0.05. 95% confidence interval, which is equal to 0.05 level of significance. At 0.05 significance, the tabulated value Z alpha equal to 1.96. This is we know. And we need to find out confidence interval for the single mean. What is the formula? X bar plus or minus Z alpha into sigma by root n. But sigma value is not given. You can take standard deviation of the sample value S. Z alpha value we know that 1.96. And we substitute in this formula, we will get the confidence interval is 7,899.43 to 15,690.57. This is the confidence interval for the single mean. Suppose test of hypothesis for difference of means formula. See, difference of means and single mean comparison is, there we have only one sample, but here we are going to take two samples with the sizes n1 and n2 with the means x1 bar and x2 bar. These two samples, this sample if you take from the mean of the first population and this sample if you take from the mean of the second population. Its standard deviation is sigma 1 and this one standard deviation is sigma 2. Then the test statistic formula Z equal to x1 bar minus x2 bar by under root of sigma 1 square by n1 plus sigma 2 square by n2. Sometimes we don't know the values of sigma 1 square and sigma 2 square. In that case, you can replace standard deviation of sample. These two are standard deviation of populations. Instead of standard deviation of population, we can replace with standard deviation of the samples. So, in that case, formula is x1 bar minus x2 bar by under root of s1 square by n1 plus s2 square by n2. Sometimes the two samples we can draw from the same population. That means sigma 1 equal to sigma 2, which is equal to sigma. In that case, the formula will be like this. Instead of sigma 1 square, you can replace with sigma square. And instead of sigma 2 square, also you can replace with sigma square. So, in that case, the test statistic Z equal to x1 bar minus x2 bar by under root of sigma square by n1 plus sigma square by n2. We'll see one problem on this topic. If you observe a sample of students drawn from two universities, their mean and standard deviations are calculated and shown below. Test that significant difference between means. Two universities are given and first university mean x bar, first one, that's why x1 bar is given, and second university mean x bar. It's the second one. That's why x2 bar. It's the standard deviation S1, S2. And the first university students sample size N1 and large samples we are going to test that is there any difference between two means. That's why we can use test of hypothesis for difference of means. And alpha value is not given. You can take general alpha value, level of significance 0.05. At alpha equal to 0.05, Z alpha is 1.96. We are going to follow the test of hypothesis procedure. First step, we are going to set up null hypothesis. That means there is no difference between the given two sample means. And in alternative hypothesis, we are going to take against null hypothesis. That means there is a difference between given two mean samples. And level of significance alpha equal to 0.05, we can take Z alpha value 1.96 from table. And test statistics Z equal to which formula we are going to use? Because S1 square, S2 square values are given. That's why instead of sigma 1 square, sigma 2 square, we can use this formula x1 bar minus x2 bar by under root of S1 square by N1 plus S2 square by N2. We simplify it, mod Z value we are going to get 0.63. But this mod Z value, what is Z alpha value? 1.96. Mod Z is less than Z alpha. That means we accept null hypothesis. Accepting null hypothesis means there is no relation between the means of the given two samples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.